Ask me, you've already done sine and cosine, so now it asks me to sketch the graph of e to the x. So it's hard to graph, right? What do we say e is the number it represents? What's that number? 2.7, 2.71 is what we approximate it as. So at 0, it helps if you got a pen there, Miss Moore. And it's turned on. All right, at 0, we would have 1. At 1, we'd have almost 3. So we've got this nice exponential curve. Okay, so there's not a ton of points we could get because obviously their values we can't graph. Okay, so how would we describe that graph? What's it doing? Yeah, it's increasing. It starts close to 0. It increases and grows to infinity. Okay, so then it asks you to take your toothpick. All right, take your toothpick tangent and talk about what do those slopes do. Okay, they do the exact same thing, right? They start close to 0 and then the slopes begin to increase and they get steeper and steeper. So they seem to do the same thing as the function. What did you notice when you filled out the chart? Yeah, the f of x values and the f prime of x values should have worked out to be the same. So 0.049, 0.049, 0.135, and so on, okay? At 0, we would have both had 1, 2.718, 2.718. Okay, that is not a coinky-dink. That's on purpose, right? The derivative of e to the x, the slope of e to the x, is the function itself. Okay, so our best guess for f prime, it's the exact same function. Okay, they are exactly the same, right? So the derivative with respect to x of e to the x is e to the x. Okay, easiest derivative you'll have to remember. Okay, the derivative of e to the x is e to the x. Okay. All right, so then it asked me to do the same thing, all right, with ln. Okay, they're like, hey, let's kind of do the same thing with ln and let's talk about what happens there. All right, so remember ln, a logarithm graph, it flips x and y for e, okay? And so if we graph it, we would have 1, 0, and then 1, 0, and then 2.7 and 2. Okay, so, or 1, sorry. So it looks something like this. Okay, it looks something like that. So there's our logarithmic function, all right? Where do our slopes seem to be the steepest? Yeah, as we get closer and closer to x being 0, okay? So slopes are steepest close to 0, okay? And they seem to be flattest as x gets very big. All right, so I would agree with that. Okay. So again, just looking at the slopes, remember slopes are the same thing as our derivatives. So then it asked me to evaluate some things. We're going to get a bunch of decimal values here. If I do just ln of x, at 1 I'd get 0.693, 1.099. So we're just plugging those in on our calculator. 1.792. But then it asked me to do g prime of x. I'm actually going to represent them in fraction form because I think it's going to help you to see it better. Okay, you're going to get a lot of decimal values. It's okay. For the first one, you should have gotten 1. For the second one, you should have gotten 0.5. What fraction's that? 1/2. The next one, you should have gotten 0.333333333. What fraction's that? 1/3. For the next one, you should have gotten 0.25, which would have been 1/4. The next one, 0.2, right, which was 1/5. Are you seeing a pattern? And then, 1/6, 0.1833333. Is that right? 6, 3. Yes, 6. That's close. All right. And so that would give me 1/6. Okay? So now, what do you think is your best guess for the derivative? This one's a little tougher. Okay? When x was 1, I got 1. When x was 2, I got 1/2. When x was 3, I got 1/3. 1 over x. Okay? So the derivative with respect to x of ln is 1 over x. Okay? It's the reciprocal of that x value. Okay? All of that comes from just looking at the slopes and looking at what the function does. And a lot of times, not always, but a lot of times, we can build those next derivative formulas from things we already know. Okay? So that's kind of what this was about. So let's pull it all together and talk about what our problems are going to look like. Okay? So these are your first 4 derivative formulas. Okay? Yesterday we learned the general power rule. Okay? These are things that would be great to go on your reference sheet. Okay? So the derivative with respect to x of x to the n was n times x to the n minus 1. That was our general power rule. Okay? Then we started our trig functions. Okay? We started our trig functions. So derivative with respect to x of sine is cosine. Derivative with respect to x of cosine is negative sine. These next 2 functions are referred to as transcendental functions. If you get to college and they say something about a transcendental, they're talking about e to the x and ln. Okay? I don't expect you to know that. All right? But the derivative with respect to x of e to the x is e to the x. And the derivative with respect to x of the ln of x is 1 over x. Okay? So now I can do derivatives by hand for a lot more than just power functions. Okay? We can do a lot of things now, which is nice. Those are the ones we got to know. If you want to add them to your formula sheet so you got them all in one place, that'd be a great idea. Okay, so let's do a derivative. Let's do one together here, number 4. The first one. So it gives me f of x is equal to 3x to the 5th minus sine plus e to the x. And it wants me to differentiate. We're going to take it a term at a time. Oh. So f prime at x, okay? 3x to the 5th, what's its derivative going to be? Good, 15x to the 4th, okay? Minus the derivative of sine, which is what? Cosine, plus the derivative of e to the x, which is e to the x, and I'm done. Okay? So learning those formulas helps me to do a lot more derivatives. Y'all try the second one. Okay, and that's a square root of x. It looks weird, but that's what that is. Okay. Yes? Because when you do the numerical derivatives, they're exactly the same. Yeah, when you filled out that chart, e to the x, the actual y values, the slopes are exactly the same between the original function and the derivative. Yep, it's all the same. Okay, I rewrote that one as x to the 1/2, okay, just to remind me that, hey, that is a power function. And so if I do y prime, derivative of 4x to the 1/2. Good, 2x to the negative 1/2. We multiply, subtract 1. Okay, so 1/2 times 4 is 2. 1/2 minus 1 is negative 1/2. Derivative of ln, 1 over x. Okay, minus derivative of cosine, negative sine. So what's that actually going to give me there at the end? Plus sine. So 2 over square root of x plus 1 over x plus sign. Okay, on a multiple choice, you'd probably see that pink answer, okay, where they'd throw everything downstairs. Okay. All right, let's look at that next one. Okay. It wants me to write the equation of a line tangent. We're going to write tangent line equations always. Okay? Take a second and see if you can try get number 5. All right, if we're going to write the equation of a tangent line, what are some things that we need? We need a point and a slope. We need the slope of the tangent, which is the derivative, and we need a point. Okay? Anytime we write an equation of a line, we need a slope and a point. Okay? So let's start by taking the derivative, f prime at x. Derivative of x squared would be 2x. Derivative of negative 3 cosine, okay? That negative 3 stays there, but what's the derivative of cosine? Negative sign. So the negative and the negative is going to make it a positive. So plus 3 sine. And then the derivative of e to the x is e to the x. Okay? The point that I'm concerned with is x is equal to 0. So I need f prime at 0 to get my slope. Okay? So f prime at 0. 2 times 0, 3 times the sine at 0, plus e to the 0. Okay? 2 times 0 is 0. What's the sine at 0? 0. So 3 times 0 is 0. And what's e to the 0? It's 1. So my slope is 1. Okay? The next thing I need is my point, my ordered pair. So I'm going to keep the 0. To get the y value, I plug it back into the original function. So f at 0. 0 squared minus 3 times the cosine at 0 plus e to the 0. All right, so we do a little arithmetic there. Okay. 0 squared would be 0. What's the cosine at 0? 1. So that's going to give me a negative 3. And what's e to the 0? 1. Common mistake. Okay. We'll be so excited that there's a bunch of zeros up there. We'll say e to the 0 is 0. Okay, just know, think about that. E to the 0 is 1. So my y value is negative 2. So there's my point. Okay, now I've got the 2 pieces I need to write my tangent equation. Y equals slope, x minus the x value, same y, or opposite x, same y. Could you also have just written x minus 2? Sure enough, okay? They will accept the first answer because point slope and we don't have to simplify. Okay, you will always use point slope, which is nice. Okay, question, nothing about that changes. All right, if you're asked to write a tangent line, find the derivative, that's the slope of your tangent, find your ordered pair, always. Okay, all right, so then the last thing that we have to be able to do today is to recognize the limit definition of a derivative. Okay, so when I tell you on free response, they will not ask you to do the limit definition of a derivative. We ain't got that kind of time. Okay. However, in a multiple choice, they may ask you to evaluate a limit, and it's going to look terrible. All right, it'll take you 10 times as long if you don't recognize that it's a derivative. So let's go back and look at those limits, okay? We said the limit as h approaches 0, f of x plus h minus f of x over h. That means derivative, okay? My other limit definition that we use most frequently, limit as x approaches a, f of x minus f of a over x minus a. Okay. When we see derivatives set up like this, okay, it'll have h equals 0, but it'll have something in there for x in the first one. In the second one, it'll be as x approaches a number, and so there will be something in there for the a's, okay? So a will be replaced. So in this one, x or a is replaced, right? And so when we see those, we need to know that x or a has been replaced. First thing we have to do, pick out f of x. What's the function? All right. What are we adding h to? All right. Or if it's a plain f of x, what is that function back there? Okay. Figure out your x or your a. What is that value they want me to use? Okay. So what number is included in the limit? Then to get our answer, we take the derivative of f of x evaluated at that number. Okay, so it's about recognition. When I see this nasty limit, can I save myself some time because I recognize it's a derivative formula? Okay, so let me just show you several of these. So either the x or the a is going to be replaced. It's important for me to pick that out. We'll pick out our actual function, which is our f of x, okay? And then we'll take our derivative. Okay. So looking at the first one, all right, on number 7, is that the first definition or the second definition? It's the first. That h approaches 0. You can tell it's x plus h over h. Like that is for real the derivative definition, okay? So what's the x value that x value that we're using? What's the number in that problem? Pi over 3. What's the function in that problem? It's always the second term, hint, hint. What are we doing to the second thing? It's sine, okay? We're taking the sine of what we plugged in, so that is my function. So the answer that I want here is f prime at pi over 3, okay? F prime at pi over 3, that's going to be my solution, right? What's the derivative of sine? Cosine, and I'm going to evaluate cosine at pi over 3. What is the cosine at pi over 3? 1/2. So that whole limit, I could do that whole limit. I could try to simplify the algebra. I would have to use a trig identity because I got a sum of two angles. Or I can recognize it's a derivative formula and just take a derivative. Okay, much easier than doing the limit. Okay, all right, look at the next one. So I've got the limit of the square root of t minus 3 over t minus 9. We're taking the limit as t approaches 9. First definition or second definition? Second. What's the a value? This one's tricky. 9. It's what t approaches. Okay, a is 9. Now, what is my function? It'll always be what's sitting right there in the beginning. What's f of t? It's just the square root of t. Okay, it's just the square root of t. It's whatever's sitting in that first position. Okay? So then we're going to take a derivative. So I'm going to take f prime at t. That's t to the 1/2. Okay? 1/2 t to the negative 1/2. And what are we going to plug in? A 9. Okay? So I want 1/2 over the square root of 9, which would be 1/6. So it's a recognition. You have to get used to seeing that derivative. If it's the h approaches 0, your f of x is always what's second. If its limit is x approaches a, your f of x is always what's first. That's how I remember it. Okay? All right, let's look at these last two. We're going to be done. All right, here we go. What is your x value in the first one? Pi. What's your function? Cosine. Okay, so let's take a derivative. Derivative of cosine is negative sine. We're going to evaluate it at pi. It's the opposite of the sine at pi. 0. Yeah, the opposite of the sine at pi is 0. Okay. All right, last one. This is a little bit tricky too, just because of how it's written. Limit as h approaches 0, and there's an h in the denominator. It is a derivative if it's set up like that, okay? What is the x value we're plugging in? 2. It's 2. It's whatever is in that second parenthesis, okay? We're plugging in a 2, all right? It looks like, why would it not be a 1/2, okay? Remember, it's f of x plus h. So I have put 2 plus h in a denominator, so what does that make my function? 1 over x, okay? F of x is 1 over x, which is the same thing as x to the negative 1 power, okay? So if I do f prime, that would be negative x to the negative 2, or negative 1 over x squared. And I want to evaluate that at 2. So negative 1 over 4. Right? You have to practice those to get used to seeing them. Okay? Because they're going to look weird. Right? They're going to look weird. Your lesson practice for tonight is actually just the, it's from CalcMedic. It's the practice that goes along with those two investigations. Okay? So it's asking you to do some things. It's on a worksheet, 2.7, that goes with what we just talked about, okay? So it goes with what we just talked about. Now, I need to make a little disclaimer, okay? I don't preach very many sermons, but I'm going to preach one right now, okay? Somebody wake Marshall up. I need him to hear it. Okay. All right. Your quiz grades will not get better if you don't practice daily, okay? You cannot just come in here and listen to me every day and think you're going to make an A in here, all right? It won't work, okay? You've got to do a little bit of practice every day. You don't have to do every problem, but you got to do something every day. You got to go home and spend some dedicated time working on it. It's why your grades are not as what they're used to, or not as high as what you're used to them being, okay? Now, I'm not in your head. I'm not at your house. I'm not, okay? But I can tell who's practicing and who's not, okay? You can just tell, right? And you can't cram it all in the day before. It won't work. There's too much, all right, that you have to know, okay? So do yourself a favor, all right, so that your mama doesn't have to call me or fuss at you, okay? And it's just different than pre-cal, okay? It takes just a little bit more than what you've done before because you deserve better grades than what you're getting right now. You're too smart, all right, to not get the grades you should be earning. All right, everybody feel me? Okay, all right. That's all I got to say about that. All right, feel like Forrest Gump. All right, so do your wrap up. It is on Google Classroom, and you have worksheet 2.7. Tomorrow is your quiz 2.4. Okay, go back, really dig in. All right, you will use the limit definitions for derivatives tomorrow. Okay, that's the work I will ask for. Okay, so be sure you practice that. Okay? All right, there you go. Good job. Just gets better from here.